All right. Good afternoon. It looks like it is time to go ahead and get started. So, our goal today is, can you describe the effects of any transformation? And so I have a starter out there that I highly encourage that you do. And we're going to open this up and we're going to complete most of this together. So I have it open. To be honest, it was kind of hard to find stuff that matched what they were wanting me to teach you. And in the textbook, I wasn't too happy with what they have there either. So I have this page, but a lot of it probably we're not going to actually do together. There's a lot of it that I feel is maybe kind of confusing. So the first thing, we're just going to talk about transformations. And so we talked about transformations with absolute value. And we talked about, like, if we changed the number in here, it moved it left and right. And we said if we changed the number here, it moved it up and down. So it may not be a bad idea to just revisit what we said. So we said this number here, that moves it left and right. This number, the plus C, and notice we don't have absolute value, but the transformations we talked about actually apply to any function. So if there's a number on the outside, it moves it up and down. Okay. And then we already talked about the A value. What does the A value do? Oops, I want to leave that red. Let's see, A value right here. That takes something and it either stretches it or compresses it. And it could also reflect over the x-axis. So it could do all kinds of things. So the A value could stretch, compress, or even reflect over the x-axis. Okay. Now there's also this K value that it could reflect it over the y-axis, and it also, you could call it a stretch and compression. We're not going to focus in on those. We're going to focus mostly when what happens when this changes, when this changes, and when this changes. And we're not going to worry about this, but technically if you made that a negative, instead of reflecting over the x, it would reflect over the y. And it also causes stretches and compressions, just the other set of vertically, it's horizontally. I get the two confused myself. Now we have some different functions, and they actually apply to all these functions. So we're going to spend a lot of time on this function. This is what we call a quadratic function. And so this is what you could do to a quadratic function. Square roots, we're going to spend time later in the semester going over transformations of square roots. This is what we call a rational. You could do transformations. And then usually when you get into like trigonometry is when you start talking about sine, but you could do transformations with that. And then exponential, we'll spend time on exponential. So pretty much we have all these different units, and the transformations apply to all of them. But this is kind of confusing, so you could ignore that. So as a reminder, if I put a negative out here, so if there's a negative, we call that a reflection across the x-axis. Okay. And if there's a negative here, which we're not going to focus in on, it does a reflection across the y-axis. So this is just a fancy way of saying, whether it be absolute value or it be quadratic, that if you put a negative outside, and this is function notation, so a negative in front of f of x, that's telling you, okay, reflect it over the x. And the point xy, becomes x negative y. So in theory, you could just change all the y values to their to the opposite, and you could graph it. Here, you got xy becomes negative xy. All right, here, and they're using different terminology. So instead of using the word expanded, we're going to use the word stretch. So I'm going to cross that part off. Well, that didn't work. Let's see. Oh, I know what I could do. So instead of saying expanded, kind of worked, not really. What we're going to say instead is we're going to say stretched, just to be consistent with what you guys will see on the district assessment. So stretched and compressed, but technically you could say expanded, okay? And so we talked about this. If I put a number out here, in front of f of x, if it's bigger than 1, it stretches it. If it's between 0 and 1, it's compressed. And then if you want to look at the coordinates, the coordinate x comma y becomes x comma ay. So you just multiply all the y values by this number. And again, we're not going to go into horizontal stretches. If I see this notation, it means we need to move it up and down. So that's what vertical would mean, up and down. Remember, when C is positive, it goes up. And that's what this says. When C is positive, it goes up. When C is negative, it goes down. And then when you have something inside the parentheses, remember it's the opposite. So if it says negative, it goes to the right. And if it says positive, it goes to the left. So horizontal, this would be left and right. Okay. So I have a function. I know it's a function because it passes the vertical line test. And what they want me to do, when I want you to take the function that's here and add 6. Now, because the plus 6 is outside of parentheses, all this is saying is move the graph up 6 units. That's all it's saying. Okay, so they want me to transform this by moving every point 6 units up. So instead of a negative 6, 0, it's going to go 6 up. Instead of negative 4, 2, it's going to go 6 up. So you're going to take this whole graph and move it 6 up. And we're going to do that down here. So take negative 6, and you're going to move it 6 up. You could just add 6 to this number if you want. So it'd be negative 6, 6. So it started off here, 1, 2, 3, 4, 5. This is where it started, right? And they want us to move it up 6. So it's going to go up 1, 2, 3, 4, 5, 6. That's the new one. This point starts at negative 4, 2. 1, 2, 3, 4, 2. And we're going to move it 6 up. That's what this notation means. Move up 6. So I'm going to take this and move it up 6. 1, 2, 3, 4, 5, 6. Take the point 0, 4, move it up 6. So start it off right here. You're going to move it up 6. 1, 2, 3, 4, 5, 6. So instead of 0, 4, it becomes 0, 10. Or something's not right. 1, 2, 3, 4. If I move it up 6, 1, 2, 3, 4, 5, 6. Oh, they counted from 11 to 11. Okay, so this is 10. So move it from 4 to 10. I'm used to 10 being the very top. And then finally take 2, 0 down here. And again, what's the transformation? Move it up 6. So 1, 2, 3, 4, 5, 6. So what we started off with this function. It went from here, not that one. Started from here, and went up, and then it went to here, and then it went up there. Oh, nope, it did not do that. It went from here to here. Let me just go confirm. So this was my original function. And they wanted me to take the function and just move it up. So now, after you move it up 6, notice it looks the same, it just moved up. Okay, so this was the original function, and this is my transform function. Okay. In geometry, we use notation. We would use a little prime symbol to show that this was the transformed one. You might also see this as written as f of x, and that written as g of x. All right, so on B, we have x plus 2. So remember, when it's inside the parenthesis, when it's plus 2 and it's inside the parentheses, that talks about left or right. See, when it's in the parentheses, it's left or right. If it's negative, let's see, when it's negative, the graph goes to the left. So mine plus 2, you need to move the function. I really should say function. Move the function to the left 2 units. Okay. And I'll let you do that yourself. So you're going to take all of these points. I would graph them again. And then you're just going to move them to the left 2, left 2, left 2. And your shape should be the same. It's just moved over 2 units. So I'll let you do that part yourself. Domain and range. Almost forgot that. So domain, and we're only talking about the new function. The domain would be from here. That's where it starts, and this is where it ends. So left or right, I would say domain is 1, 2, 3, 4, 5, 6. And again, I'm ignoring this part. I'm only looking at the transform function. They want the domain of the transform function. So I think I counted 6, -6 to 2. So that is the domain, -6 to 2. And it includes those 2 points. Notice that on the original function, before we moved it, it was also -6 to 2. So the domain didn't change. Now, range, it started off from 0 to 4. But now, because we moved it up, our range, so this way, that's the bottom point, to this way. So from here to here is my range. That's 1, 2, 3, 4, 5, 6, 6 to 7, 8, 9, 10. So the range is 6 to 10. So the range changed because it used to be only 0 to 4. So by moving it up 6 units, it also moved the range up 6 units. Okay. And I'll let you do that part yourself. Now let's talk about stretches and reflections. So if I have -3 f of x, let's talk about each of these pieces by itself. The 3, so if it's outside in front of f of x, we say stretch or compressed. If it's bigger than 1, we say stretch. There's a fly that keeps flying around my head. If it's between 0 and 1, we say compressed. And if you forget, where'd you go? Right here, A. If it's bigger than 1, we say stretched by a factor of A. And if it's between 0 and 1, you say it's compressed by a factor of A. And then how do you change the graph? If you start with XY, it becomes X, AY. Okay. So the 3 stretches. Okay. And then that negative sign, this negative sign right here, that negative sign is going to reflect over the x-axis. So what's going to happen is you're going to take this graph and it's going to flip over. And also you're going to take each of these values, you're going to take each of these coordinates, and I'm going to read the rule again. It says XY becomes XAY. So really, so what they're saying is the X value stays the same, but you're going to take -3 times the 2, -3 times the 0, -3 times the 4, and -3 times your 0, and that should do it all for you. So the new one, if we multiply this by -3, that becomes -6. So I'm going to go plot -4, -6. Now let's start with this one. If I multiply that by -3, 0 times -3, that's still 0. So I'm going to go plot -6, 0 right here. And then I multiply this by -3, that becomes -6. So I'll plot -4, -6. There we go. And then I multiply this by -3, and that becomes -12. So I'm going to plot 0, -12. Be about right there, approximately. And then I'm going to multiply this by -3, but it still stays 0. So I'm going to plot 2, 0. It's going to stay the same. So what happened was we took this picture, we flipped it over, so it's going to be under, and we stretched it by a factor of 3. So it's going to look the same, but it's going to be kind of skinnier, a little more stretched out. And so that's what it's going to look like. It's going to look like from here to here, and then here to here, and then there to there. So notice, pretty much the same shape, just flipped over and stretched by a factor. Now, I don't want you worrying about what happens when the number's inside here, so we're going to cross that off. I don't see the need to cross that off. We don't need to do that. So we can cross this off. And I'll let you fill in the domain and range yourself, so you could do this part yourself. Now you could also do a combination. And these are pretty complicated combinations. That was a huge jump. I need to change this practice. I just noticed that. Let's make it simpler. Let's change this. I'm changing the problem to make it easier. So let's cross that off. And let's change it to y equals negative f of x plus 4. So you're going to take this function and you're going to describe what changes. Actually, we're not graphing, so I changed my mind. We could talk about it. The 8, so if I see the 8, remember if the 8's on the outside, it moves it up and down. Because it's positive, I would say it moves it up. So that 8, I would say it moves up 8 units. Okay. And then the 3, we could go look at, see what that means. So when the number's inside, it talks about a horizontal stretch. So I really don't want you to worry about that part. So like, let's just change this actually to just y equals f of x plus 8. That'll be our new problem. And I'll try to change it on the practice. And then let's let this be y equals negative f of x minus 4. Let's just change it to that. So assuming so what I'm saying is, let's get rid of this and change it to this problem. And let's get rid of this and change it to this problem. So what does the negative do? What does the negative do here? And I'll update it on the regular one. Here, again, I feel like it's too complicated. So we're going to do y equals 4f of x minus 2 minus 5. And I'm going to get rid of this part. Okay. So what does the 4 do? What does the negative 2 do? What does the negative 5 do? Put the description here. And I'm going to change this to y equals 2. Actually, let's do a little bit of a negative. Let's do negative f of x minus 12. What happens to it? Okay. So describe the transformation. So we'll do this one together. So I would say the negative reflects over the x-axis. The negative 12 moves it down 12 units. Now, if the 12 is in parentheses, it moves it left and right. The function y equals f of x has been transformed. Describe the values of a, k, d, and c of each of the following. And they're talking about stuff I don't really want you guys to worry about. So let's actually cross this one off. Okay, so what you should be doing for your practice, we did these notes. I said, move this to the left 2 units. So we're going to do that over here. We're going to put down the domain, put down the range. I crossed this off for you. We did this one together. I said, put down the domain and the range. And I changed some of the problems. So we said that this moves it up 8 units. You're supposed to describe what the negative does. What does the negative 4 do? What does the 4 do? What does the negative 2 do? What does the negative 5 do? You're just going to list it, and that's your practice. I would also encourage that on your Delta Math, if it ever loads. Yes, that's me. there'd be a really good one, because I didn't really save much for you guys to do. Transformations of functions. This would be a really good one to try yourself. Usually it lets me click on it. I guess I could type it over here. Okay. So transform the solid black line to match the dotted line. So you start off with this. First thing you want to do is you want to change the symbol in front to flip it over. It's called a reflection over the x-axis. Watch this. It's going to flip over. All right. Now here it moves it left and right. I want to move it to the right 5. So because it says plus, I have to type this in as -5. And watch this. It moves it to the right. All right. Now I want to move it down 1. So I put -1. There you go. So this would be a really good one. And notice this is the new function. All right, so I would highly encourage that you do this Desmos. And I guess we have the ESL announcement right now, but I'm going to end the video right here. But looks like we do have